Hello again. Right now we're going to be talking about Newton's second law of motion, and that shows the relationship between some of the things you've just learned about: force, mass, and acceleration. Puts all those together in a package, and we figure out how those are related to each other. So let's get started. First, make sure you've downloaded the Cornell Notes attachment to the K-mail that has this video link. Open it and either type into it or print into it to take notes. You'll want to add to the notes that you already took, but make sure you have the keywords in there at least, and make sure you write in there the concepts that we're talking about today involving force, mass, and acceleration. So pause the video right now until you're ready to start taking notes again. Before we do that, we're going to talk about the grade check assignment. That's something that's very important for you to do right away. How do you find that? Well, you go to your science course homepage, click on Grade Check Assignment, and that's where you'll find these instructions. What you're going to do is go to Doc Sharing, and then scroll down a little bit, click on the Gradebook Check Assignment, download it, print it, fill it in with your learning coach, put down all the grades for all of your courses, and then send them to the proper Dropbox for each of your courses. That's all there is to it. It's very simple. Contact your teachers if you have questions about that. Here's what we're going to do today, or right now. We're going to talk about what we had in the last video, talk a little bit more about how to take notes. We're going to learn about Newton's second law, and then I'll tell you what's coming up next in class. So make sure you've got a piece of paper and something to write with, or a document to type into. Last time we talked about Newton's first law of motion. That's the idea that an object that's at rest, or an object that's not moving, is not going to move unless a force acts on it. And an object that is moving is going to keep going in a straight line in the same direction at the same velocity unless a force acts on it. So unless something changes its direction, causes it to speed up or slow down, those are accelerations, right? Unless a force acts on it, it's going to keep doing what it's been doing, whether it's at rest or whether it's moving. So a force is required simply to change an object's velocity. That's all that it is. So today you're going to be able to describe Newton's second law of motion. So make sure you have these vocabulary words in the left column of your notes. And as we go through here today, look for main ideas, main concepts, like write down Newton's second law of motion in the left-hand column, and be ready to fill in something in the right-hand column so you can have those notes stuck in your mind forever, okay? Okay, so write in the left-hand column Newton's second law, and then write this: the acceleration of an object is determined by its mass and the force acting on it. And we're going to put some math with this, some very simple mathematics, but a combination of the mass of an object and the amount of force, that is something you can calculate and determine how much force there is. So what's a force? It's a push or a pull that may change the motion of an object. It can increase or decrease speed. It can change something's direction. Mass is simply how much stuff there is in an object, how much matter there is. And so the more mass an object has, the more force it takes to move it. It has more inertia, which is the tendency of an object to resist changes in its state of motion. Think about that lazy cat on the car dashboard in the last video, right? It's very resistant to motion. Once again, acceleration, that's a change in velocity. There's a lot of acceleration going on with this automobile here, this drag racer, right? So, force, the amount of force required to move something, is mass times acceleration. So, this girl is putting a large amount of force on a very small, not very massive object. So, is there going to be a lot of acceleration? You bet. You bet. A lot of acceleration if you've got a lot of force and a small mass. On the other hand, if you have a small amount of force and a large mass, you're going to have very little acceleration. That's how those things all relate to each other. Okay? So we can go to the lesson here. Let's go to lesson 2.06. And there are some cool simulators here, things to try out. As you can see, you can measure the acceleration on an object. Yeah, there's the amount of force that this object had. Okay, let's reset this. The amount of force needed to stop it, 4 newtons, okay? Well, let's try it with a larger object, okay? Here we had a 5 kilogram object. Here's a 10 kilogram object. And let's launch that. And we can see how much force is there compared to the first one. Let's see, it's going at the same amount of acceleration, the same amount of speed. Only 4 newtons here versus 8 newtons here. Okay, so the more mass, the more force. Similarly, the more acceleration with the same amount of mass gives you more force as well. Okay, so to change a moving object's direction, the object must overcome its momentum. Momentum is the mass multiplied by the velocity. That's another way to look at this. That's momentum. So once again, Newton's second law of motion says that force is produced by multiplying mass times the acceleration. That's all there is to it. F equals ma. Okay? There's some key words here. You can pause the video to make sure that you've got all the definitions here properly. And don't forget the definition of Newton's second law. Oops, where did we go? Newton's second law here, that force is produced by both mass and acceleration. F, and write this down, F equals ma. F equals ma. Make sure you have that. Okay? So you're going to want to take the 2.06 quiz. Make sure you take that, review the lesson, and next time we're going to be learning about Newton's third law of motion. It's what makes rockets work. Okay? Think about what that might be. And that's all for now. Thanks a lot. Bye-bye.